For number 1 here, we're just going to list the sample space. So the hot dog stand offers both small and large hot dogs. So I'm just going to go S for small and L for large. And that's really just the two things that you can have there. Number 2, we've got a bag containing 3 real diamonds, 2 fake diamonds. You pick a diamond, so the sample space would just include those different results. So they had 3 real, so I would call it R sub 1, R sub 2, and R sub 3. And then the 2 fake diamonds, so F sub 1 and F sub 2. And again, that's just each of those things is the possible outcome for that event. And number 3, this is a 2-part, so you could use a product table. The first part would be whether it's a waffle cone or a bowl, and the second part would be the which of the 4 flavors. So if your product table looks something like this, waffle cones and bowls on the left, strawberry, chocolate, vanilla, and mint chocolate chip on the top. So really just the WS there, WC, WV, and WM. So again, just the waffle cone with each of the 4 flavors. And same thing for the bowl. And really I should be writing that out in set notation, but for saving time and space I'm just going to leave it in the table. But again, those 8 things, that would be the possible sample space here. Number 4 is very similar to number 3. We've got 2 choices for bagel, we got plain and onion, and then 3 choices for spread. We could go with nothing, butter, or cream cheese. My abbreviations for this then: plain, or P for plain, O for onion, the empty set symbol for no spread, B for butter, and C for cream cheese. You could obviously do other notation if you liked, but up to you however you do that. And again, I really should list those out in set notation, but just for time and space, I'll just leave those in my product table. So those are the 6 possibilities. Number 5, again, gave people a lot of trouble on the quiz. We have 2 rooms that need to be painted. They can either be painted white or yellow. And so really what we're looking at would be another product table. Room 1 on the left and room 2 on top. Each room could be painted either white or yellow, so it's possible that they'd both be white, or even that they would both be yellow, or the first room white and the second one yellow, or the first room yellow and the second one white. So those 4 possibilities. Again, I probably should write it in set notation, but just for saving time and space, those are the 4 things that would be in that sample space. For number 6, we have the 3 types of sandwiches and the 3 types of bread. So ham, turkey, and chicken, white, multigrain, or rye. So again, just a 3x3 grid for this one. Again, filling in the product table so we can see what different 9 combinations there are. Again, I'll just leave it here, although I should put it in set notation. But again, we can see the different 9 combinations there. Starting with number 7 then, we're just looking at the possible outcomes, not listing them all out. So in 7, we've got a football player attempts 6 passes. In overtime, each attempt results in a completion, an incompletion, or a turnover. So really we have 6 different parts to that. Each part has a possible or possibility of 3 different outcomes. So we multiply those together, we end up with 3 to the 6th power. And so 729 different possibilities. Number 8, really the same question, just 4 passes in overtime. So 4 parts to that. Again, each one with 3 possible outcomes. So 3 to the 4th power, or 81 different ways that could work out. For number 9, we have a spinner is either going to land on red or blue. You spin 6 times, so it would be 6 parts to that task. And then you roll a 6-sided die. The spinner has 2 outcomes for every, or 2 possible outcomes for every try. Not sure why I put a 2 there. Of course, that should be a 6. So we end up with 2 to the 6th power for the spinner 6 times, and then multiply that by 6. And we end up with 384 possible outcomes for that one. For number 10, the first choice we have is the type of car, either sedan or hatchback. So that is 2 choices. And then we have a choice of any of 6 colors, so that would be 6 choices. And then we have 6 optional features. So really, that's 6 optional features, each of which are going to be either on or off. So 2 choices for each feature. Do you want it or not? And so we end up multiplying all of those together. Ends up being 7 2s, so 2 to the 7th power times a 6. And we get 768. For number 11, we are just determining whether it is a permutation or a combination. So with 11, choosing a captain and a co-captain. With that, again, the important thing is it's a captain and a co-captain, so they are different. So we would go with a permutation on that one. And in number 12, we have Shreya with assignments and 5 subjects. She only has time to do 2 assignments. And so in this case, it doesn't really matter what order she does them in. So that would be a combination. For number 13, we'll actually determine how many possibilities there are in the scenario. In this case, we have 40 applicants for 2 manager positions. Since they're both manager positions, they're the same, so it does not matter the order or which one you get assigned. You're a manager either way. So we just have a 40C2, and that turns out to be 780 different possibilities. And for number 14, we have Julia. She has assignments in 7 subjects. She only has time to do 5 of them. And again, here we're just deciding which one she's going to do, not the order. So we would be using a combination. So of the 7 subjects, she's only going to have time to do 5. So that would be a 7C5. And that turns out to be 21. Let's see, for number 15, selecting which 9 players will be in the batting order on a 10-person team. Again, the key here is which players will be in the batting order, but not actually determining the batting order itself. So this would be a combination. There's 10 people on the team, 9 get to be in the batting order. And so 10C9 ends up being 10. And for number 16, the handshake question. We have 130 students at a meeting. They each shake hands with everyone else. How many handshakes were there? So again, 2 keys here. One is it's a combination, because again, 2 people shake hands. The order doesn't matter. It's not A shakes the hand of B and then B shakes the hand of A. You know, you have one handshake, so you don't look at all the different arrangements of that. And the second important thing is we're pairing up, you know, an A and a B. So really we're saying how many different pairs of people can we have, and so it's 130C2. And we end up with 8,385. So for number 17, this would be a permutation because it's a president and vice president. There are 125 students that could be elected. Only 2 will be, so 125P2. So a total of 15,500 different pairs of president and vice president. Now for number 18, it is determining the actual batting order for 10 players on an 11-person team. So it would be a permutation, 11P10. That ends up being 39,916,800. It's again a rather large number. Number 19, 15 applicants for 4 software tester positions. Since all the positions are the same, this would be a combination. 15 applicants, 4 positions, so 15C4. And 15C4 ends up being 1,365. And then with number 20, selecting which 9 players will be in the batting order. So again, difference between 18 and 20. 18 we're actually determining the batting order. 20 we're just determining which players will be in the batting order. So this would be a combination. It's 10 people on the team. 9 get to be in the batting order. 10C9 is 10. And hopefully this was helpful. And good luck on the test.